Chapter 11 is all about understanding randomness. Before we go over this chapter further, these are key terms we should know in order to understand this chapter. First, random. An event is random if you know what outcomes could happen, but not which particular values will happen. Random numbers. Random numbers are hard to generate. Nevertheless, several internet sites offer an unlimited supply of equally likely random values. Simulation. A simulation models random events by using random numbers to specify event outcomes with relative frequencies that correspond to the true real-world relative frequencies we are trying to model. Simulation component. The most basic situation in a simulation in which something happens at random. Outcome. An individual result of a component of a simulation is its outcome. Trial. The sequence of several components representing events that we are pretending will take place. At last, response variable. Values of the response variable record the result of each trial with respect to what we were interested in. The most important aspect of randomness is fair. And fair is just really two things. First, nobody can guess the outcome before it happens. Second, when we want things to be fair, usually some underlying set of outcomes will be equally likely. Randomness is not always what we might think of as at random. Random outcomes do have a lot of structure, especially when viewed in the long run. We can't predict how a fair coin will land on any single toss, but we are pretty confident that if we flipped it thousands of times, we would see about 50% heads. Like this, randomness is an essential tool of statistics. Statisticians use randomness as a tool. But without the help of computer-generated programs, the random numbers are really hard to generate. And that is what the first section of this chapter is all about. It is really not easy being random. It is surprisingly difficult to get random values even when they are equally likely. Computers have become a popular way to generate random numbers. Even though they often do much better than humans, however, computers can't generate truly random numbers either. A simulation consists of a sequence of random outcomes that model a situation. In this sequence, the most basic event is called a component of a simulation. Each component has a set of possible outcomes, which is one of which will occur at random. The sequence of events we want to investigate, called trial, usually involves several components. After the trial, we record what happened, and those are our response variables. There are 7 major steps for making a simulation in more detail. First, identify the component to be repeated. Second, explain how you will model the outcome. Third, explain how you will simulate the trial. Fourth, state clearly what the response variable is. Fifth, run several trials. Sixth, analyze the response variable. And last, say your conclusion.